Hello everyone, myself Dr. Dayanand Raje from the Department of Physics and Electronics, Rajarshi Shahu Mahavidyalaya, Latur. Now we will see here properties of the atomic nuclei. Before to study the atomic nuclei and its properties, we should know what is the difference between nuclear physics and atomic physics. The simple difference between nuclear and atomic physics is that nuclear physics deals with the nucleus, while the atomic physics deals with an detailed study of an entire atom. Atomic physics deals with the properties of an atom as a whole, and mainly due to its electronic configuration. Of course, the nucleus is a part of this, but only in terms of its overall contribution. Nuclear physics deals exclusively with nuclei, their structures, properties, reactions, and interactions. To understand the properties or to understand the concepts of quarks and gluons, the forces within the nucleus, the study of forces within the nucleus is nothing but the nuclear physics. The application of nuclear physics is largely in the field of power generation, particularly for the generation of nuclear energy. Once the force holding the nucleus was understood, we started the splitting and fusion of neutrons. The energy evolved in the process, in the fusion and in the fission of the nucleus. The energy evolves, and this evolves energy is called as the fusion energy or the fission energies. Now the uses of nuclear physics. The continuous research in the field of nuclear physics has helped in find various other uses. We know the nuclear medicines, nuclear weapons, and have been found its uses in geology and archaeology in terms of carbon dating. An atom is made of a dense central hard nucleus. As you know that the whole mass of the atom is concentrated in the nucleus. Why? It is called as whole mass of the atom is concentrated in the nucleus. Because the mass of proton and mass of neutrons are in the nucleus, and mass of electron is outside the nucleus. Outside the nucleus. The mass of an electron is near about 1836 times less than the mass of proton, and the mass of neutron is slightly heavier than the proton. As a whole, the atom is considered as the neutral. Whole atom is a neutral. Why it is called as a whole atom is a neutral? Because the total positive charges which are present within the nucleus are nothing but the protons, and how many number of protons are within the nucleus, that number of electrons are around the nucleus within the atom. In many places you may have seen that atomic energy is the source of energy production in terms of nuclear fission and process reaction. Atomic physics is concerned with the entire atom and how electronic configuration of electrons can change. When an atom loses an electron, it becomes positively charged, and when it gains an electron, it becomes negatively charged. As you know, in terms of the radioactivity, heavy nuclei emits the radiations like alpha, beta, and gamma, and the spontaneous emission of this type of radiations is known as the radioactivity, and this radioactivity occurs due to the decay of the nucleus. When there is a decay of the nucleus, it forms its daughter nucleus. External parameters such as temperature, pressure do not affect on the rate of the decay or rate of the radioactivity property. Radioactivity is nothing, it is based on the law of conservation of charges. The daughter nuclei will have unique physical and chemical properties, and these physical and chemical properties are different from the parent nuclei. Decay rate of radioactive material is directly proportional to the number of atoms present at that particular instant, at where we are calculating the decay rate. Alpha, beta and gamma rays are followed during the radioactive phenomena. Now, what are the nuclear basic nuclear properties? Nuclear physics is based on the forces known as the nuclear forces. The nuclear forces are strong attractive forces. Within the nucleus, as you know, that protons and neutrons are there. And due to these nuclear forces, the nucleons, it means protons and neutrons, combinedly called as the nucleons. Individually, each particle which are present within the nucleus, we can call it as a nucleons, which bind the nucleons together. The forces which bind the nucleons together in the nucleus of an atom, these are the strong attractive forces. These forces are very strong forces in nature. These forces are very strong forces in nature. As you know, the forces, gravitational forces, electrostatic forces. And it means the nuclear forces are neither gravitational nor electrostatic. Now, these forces are of three types. These forces are of three types. The forces between two protons, attractive forces we can call it as. The attractive forces between two protons, the attractive forces between two neutrons, and the forces between proton and neutron within the nucleus. These all these forces are attractive and are of the same order. Now, what is the nature of this nuclear force? Nuclear forces are very, very strong attractive forces, as you know. These strong forces are effective within very short range, that is within the 10 raised to minus 14 to 10 raised to minus 15 meter. And these forces are independent of the charges. As you know that the like charges are repelled each other according to the Coulomb's law. But within this range, that is the range that of the order of 10 raised to minus 14 to 10 raised to minus 15, there is strong attractive forces. Within this limited range, there is a force of attraction in spite of the force of repulsion is there. As a result, each nucleon interacts only with its limited number of nucleons nearest to it. And this effect is known as the saturation of nuclear forces, and we can also call it as saturation property. The proton-electron hypothesis. What is the proton-electron hypothesis? Before the discovery of neutron, as you know, the neutron is discovered by Chadwick in 1932. Before this discovery of the neutron, it was assumed by the previous physicists that the nucleus consists of protons and electrons, like the watermelon. If we consider an example of nitrogen having atomic number 7 and mass number 14, according to the proton-electron hypothesis, 7 indicates the atomic number and mass number indicates the 14. And according to this hypothesis, atomic number Z contains A protons, means mass number means nothing but the proton numbers, and A minus Z number of electrons are present. So, nitrogen nucleus would have 14 protons and 7 electrons in extra nuclear space according to the proton-electron hypothesis. This concept before the 1932 was arose because the radioactivity showed that the radioactive materials, alpha, beta particles were ejected from the nuclei of the atoms. undergoing the transformation and the presence of electrons in the nucleus. Made responsible under the same conditions, one of them might be ejected. It was also assumed that alpha particle could be formed in the nucleus by the combination of 4 protons and 2 electrons. 4 protons and 2 electrons, according to the proton-electron hypothesis. It was found that most elements are mixtures of isotopes. As you know that isotopes are nothing but the elements having the same atomic number but mass number is different. It means the same element but mass number is different. It means the mixture. Elements found within our nature are mixtures of the isotopes, and the different isotopes of an element have the same number of protons and the arrangement of electrons, and consequently their spectra have the general structure, same general structure. They are different from one another, or they are different atomic masses. Atomic masses are different. It means chemical properties and physical properties. Chemical properties are same but physical properties are different of the isotopes. And this isotopic effect is not enough to explain the hyperfine structure. What is the hyperfine structure? As you know, the fine structural line. The splitting of fine structural line into number of lines lying very close together. It means there is a spacing between the 2 spectral lines, and that spacing is nothing but 0.13 angstrom unit, as shown by the Michelson-Morley experiment later on, after the proton-neutron theory. But we are studying now here proton-electron theory. The proton-electron theory also fails to account for the order of magnitude of nuclear magnetic movements. As you know, there are de Broglie principle. According to this de Broglie principle, there is a wave mechanical argument, particle as well as wave nature. There is also wave mechanical argument against the existence of free electrons in the nucleus, because if an electron exists in the nucleus, the kinetic energy of the electron must be more than 20 mega electron volt. But the electrons of such large energy are never found to be emitted during the beta decay. The maximum energy of the beta particle emitted from the nucleus is only 2 to 3 mega electron volt. So later on, Chadwick discovered the proton-neutron hypothesis, and this is adopted by the world. And according to this proton-neutron hypothesis, a nucleus of mass number A, atomic nucleus of mass number A and atomic number Z contains Z number of protons. It means A is a mass number. A minus Z number of neutrons are within the nucleus. Z number of electrons are revolving around the nucleus so as to make atom electrically neutral. It means number of protons within the nucleus, number of electrons outside the nucleus. It means whole atom is electrically neutral, as we have explained previously in the introductory part of this session. The existence of neutron in the nucleus. The existence of neutron in the nucleus satisfies the uncertainty principle, and it explains the electron does not pre-exist inside the nucleus, but electron is formed just at the instant of emission caused by the transformation of neutron into proton. It means it is the conversion or the transformation of neutron into proton and electron, and that electron, as soon as it is created, it emits outside the nucleus, and that electron is nothing but the beta particle which is emitted from the nucleus. As you know, the beta particle have negative charge. Electron is a negative charge, so electron emits out as soon as it produced there. And the positron emission and positron emission due to the transformation of proton into neutron. How? The proton into electron plus proton is transformed into nitrogen and positron, and that formed positron escapes out of the nucleus. This is the formation of a positron. The emission of alpha particles from the nuclei of radioactive elements. Alpha particles, as you know, its atomic number is 2 and mass number is 4. It is equivalent to the helium atom. The combination of 2 protons and 2 neutrons at the instant of emission, it means it is the alpha particle. Thus, this hypothesis explains beta decay and alpha decay. This assumption is also able to explain the observed value of nuclear spin and nuclear magnetic moment. Nuclei having odd mass number will have half integral spin, and those with even number will have integral spin. There are no difficulty in explaining the existence of isotopes. Isotopes of given element differ only in the number of neutrons they contain. Okay, thank you.